Welcome back. Our objectives in this video are to determine the existence of inverse functions, confirm that functions are one-to-one using the horizontal line test, and finding inverse functions algebraically. Our first objective here, to have an inverse function, a function must be one-to-one, which means that no two elements in the domain of our function can correspond to the same element in the range of the function. Okay, so as I've listed here, kind of 2 leads to 4 and 3 leads to 4, that's not going to be one-to-one because there's 2 different inputs that result in the same output. So you can't have 2 different recipes or inputs to create the same Wonka bar or output. Now, this still is a function, it's just not one-to-one. Okay? So a function, as defined by the book, a function is one-to-one when for a and b, its domain of f of a equals f of b and implies that a is equal to b. Okay? A function has an inverse if and only if the function is one-to-one. So you've got to be one-to-one before you can have an inverse function. One way to tell if something, if a function is one-to-one, is the horizontal line test. Okay, so if a graph passes the horizontal line test, you know that it is one-to-one. So this parabola here on the right-hand side fails the horizontal line test. When we draw a line through our graph, it hits the parabola in 2 different locations. So we can see here with our parabola, -1 and 1 both result in an output of 1. So that we have 2 different ways to get 1. So a quadratic, in this case, is not a one-to-one function. So a one-to-one function is something more like a cubic. This cubic is one-to-one because it passes the horizontal line test at every location. In fact, a function will be one-to-one if the function is increasing over its entire domain or if the function is decreasing over its entire domain. So this cubic function here happens to be increasing over its entire domain. We can also find inverse functions algebraically. Okay, the process is laid out here. So first you can use the horizontal line test to decide whether the function has an inverse. Okay? In the equation for f of x, replace f of x with y. And actually we've been doing this for a while. Don't we know that f of x really is just another way to write y? Okay? So in a linear equation, we know that y equals mx plus b. Well, we've also done f of x equals mx plus b, just using the function notation. So they're just saying, instead of using the function notation, just use y. Our third step is to interchange the roles of x and y. So we'll be flipping x and y in our work. So we would do this kind of thing, and we would get x equals my plus b. And then replace y with the inverse of x in the new equation, and then verify that they are inverses by showing that f is equal to the inverse of x and so forth. So let's do a sample of one of those. Find the inverse function of f of x equals 5 minus 3x over 2. Well, looking a little bit more closely at this, this is 3x to the first. This is a linear equation. We might see this as f of x equals -3 halves x plus 5 halves. So this is a linear equation with a negative slope, a -3 halves. So it will decrease over the entire domain. So this is one-to-one, and it's going to pass the horizontal line test. And therefore, it's going to have an inverse. So let's go ahead and follow our process and find out what that inverse is. So I've already changed f of x to y. So we have y equals 5 minus 3x over 2. And now in step 3, we are going to go ahead and we're going to flip the roles of x and y. So we're going to switch those two. So we get x equals 5 minus 3y over 2. And at this point, we solve for y. So our goal here is to get y equals something. So I'm going to multiply both sides by 2. So I get 2x equals 5 minus 3y. After multiplying both sides by 2, realize my goal is to get y equals, so I'm going to take my y and add it to the other side. I'm going to subtract 2x from both sides. So I do a little moving things around here. I get 3y equals negative 2x plus 5. Divide both sides by 3. And I get y equals negative 2x plus 5 all over 3. I'll go back to my function notation. So the inverse of x equals negative 2x plus 5 all over 3. There is our introduction to one-to-one and inverse functions and how that works. And we'll get some more practice with that when I see you in class.